Hello, in this video we are going to begin our work on the demand chapter for intermediate microeconomics. Alright, so we're going to start off by deriving the demand function / curve. Now recall that with everything else held constant, a change in price will lead to a change in quantity demanded, right? That is a movement along the demand curve. So what we're going to do in this video is actually determine what our consumer's optimal demand curve is going to be given changes in the price that he or she faces. All right, so we know that a demand curve shows the relationship. Bear with me that I'm talking and typing I'm writing at the same time. I want you to use all your learning styles with this. All right, so the demand curve shows a relationship between what? Anyone? That's right. Prices and quantity demanded for a particular good. So if this is a market for blue jeans, right? Our demand curve, which is downward sloping, will show us how price, so as P1, and quantity, Q1, are related to each other. So if price should decrease, right, to P2, then we would expect that quantity demanded will increase to Q2, which makes sense. Either more people can now afford it, or the people who could afford it up here at point 1 are just buying more of it at point 2. Okay, so what we're going to be doing in this chapter, after that quick review of a demand and demand curve, what we're going to be doing in this chapter is we're going to be using the consumer theory, well, consumer consumption optimization theory, to show how a change, well, specifically to show how a consumer's choice for one good changes when the price of that good changes. Right? So basically what we want to do is combine this idea of that law of demand that we know with regards to change in price and quantity with our optimization theory, consumer optimization theory, where we're saying the consumer will always be optimizing even as they're moving from QD1 to QD2. Okay? Right, optimizing what? That's a good question. Optimizing their happiness. Okay. All right, we'll talk more about that. So holding other prices constant, well, prices and income constant, we can trace out the demand function. Right? So we can use how a change in price for one good will affect the consumer's optimal choice. Call this Q star of X changes. And with this, we trace it out. the consumer's choice as P changes with Px. Okay, so let's go ahead and jump right in. Now, there are certain things I want you to note as we go through. Right, this is going to get heavy mathematically, and we're going to be using some equations. But there are some certain things you need to just hold on to and remember what they mean. Right. So if we say Q of y is equal to d of y as a function of P of x, P of y, and I, we need to discuss what we mean here. Right, so basically what we've said is that the quantity demanded that a consumer will choose is based on a demand function for good y, right, which has the price of good x as a component, price of good y as a component, and income as a component. All right, let's go ahead and do this. So we have Q sub y here as the quantity of y demanded. D of y, that's right, this is the demand function. It tells us how these three things relate to each other to actually determine quantity. All right, and then we have P of x, which is the price of good x. That's right, you guessed that correctly. So if P of x is price of good x, what would P of y be? Yes, price of good y. And I here is income. All right, so what this is telling us here, what this equation here is saying is that the quantity of good y demanded is a function of P of x, P of y, and what's that last thing? Yep, that's right, I, which we know is income. Okay, so we've reviewed that. Let's go ahead and consider a scenario. All right, so consider this. We have two goods, right? Good x and good y. And so we choose quantity x of good x and quantity y of good y. We also have a utility function. This is very important because remember, we're considering the consumer's optimization and they want to optimize utility happiness given their budget constraint. So we need that utility function, which just tells us how the consumers rank their choices, right? Level of happiness they get from their choices, combination of their choices. Okay, so this utility function u is equal to q sub x to the power of a half and q sub y to the power of a half. Okay, now you might have seen this as I used to say this type of equation as x to the half, y to the half. The reason I'm using q sub x and q sub y here is so that we know we're actually choosing the quantity of x and the quantity of y, right, that will maximize the consumer's happiness, right? So when we have x and y in that equation, it's just telling us how this consumer determines or ranks her utility, given these two good options. Okay, so we have that there are two goods, utility function is this, and we have that with the prices P of x, price of good x, and P of y, And also, let's make this where, well, with a budget that may vary. So with this information here, we can determine the consumer, just write out the consumer's budget constraint. Okay? The budget constraint here visually tells us how this is good X, good Y, the combination of good X and good Y that this consumer can afford. Right? Budget constraint. Alright, so given this information, we'll have that all of the income or budgets that this consumer, let's call her Rory, this consumer Rory has decided to spend, I will be a function of, or is comprised of, the price of X times whatever amount of X she gets, plus the price of Y times whatever quantity of Y she gets. Okay? So the sum of these two things should be equal to our Rory's budget, her I. Now what you need to do, this is all of our information, this is all of our pertinent information. With this, we need to find Rory's optimal QY and QX for any given price of X, price of Y, and income. Right, with this, once we know income level, or her budget, or a price of one of the good X or good Y, we'll be able to determine right away that Rory is going to get QI star. Rory's going to get QX star. Now I know this is a little bit abstract, but please follow here. If you have any questions as we go through, just let me know. Email, chat, anyway. Okay, so coming into this, you should know how to find that optimal Q of X and Q of Y. This was from the consumer's choice constraint chapter. In other words, finding the optimal consumer choice. But let's remind ourselves. Okay, so we have that the optimality occurs when MRS is equal to MRT. Let's slow down a little bit here. What does this look like visually? Actually, before we do that, MRS here is the slope of, that's right, our indifference curve. MRT here is the slope of the budget constraint. Good job. So visually, what this equation or equal to sign means is that Rory is going to pick the combination of goods that sets these two slopes equal to each other. In other words, this is our difference curve, budget constraint. She's going to pick the combination of goods here, optimal point, that makes her the most happiest, right? So if we had something, let's use this. If we had another indifference curve here, let's call this IC2. Rory could afford this, right? Because it's on that budget constraint. She can also afford this. But we will see, right, just from our understanding of how indifference curves work, right, and how to represent Rory's happiness, she's going to want an indifference curve that is as high as possible, because that means that she is as happy as possible. So if Rory could get an indifference curve that was up here, we'll call this IC3, she would go for it. She would be very happy about this. But the problem is, this combination of goods on IC3 is unaffordable to Rory. She can't afford this. So she has to settle for the best possible outcome for her. which is our optimality point here at IC1. Now, this is a very important, one of the most important things you should walk away from with an intermediate micro course, right? The optimality condition for consumers' constrained choice. MRS is equal to MRT. The point where your IC curve is tangent to your budget constraint. Okay. Those two just touch each other once. Right. Notice with the IC2, it intersects our budget constraint twice. It intersects doesn't just touch it, it intersects and it does so twice. So it's definitely not what we would want. Okay, so let's go ahead and do this. So we know what we're looking for here. We want MRS is equal to MRT for Rory. We know, right, that MRS is equal to negative marginal utility. So the derivative of the utility function with respect to x, good x, and divided by the marginal utility of good y. So the derivative of the utility function with respect to, let's just write that out. So du dq of x over du dq of y. So du dq of x just says how does the utility function change when quantity of x changes, right? Du dx or du dqx. And we do the same thing for y. Now MRT on the other hand is negative p of x over p of y. Right? This is the slope of the budget constraint. Okay, so we have the framework. Let's dig deeper and actually do the calculations. Remember, our utility function is q of x to the power of 0.5 and q of y to the power of 0.5, where 1 over 2 is just the same thing as 0.5. Okay, so we need the derivative of this function with respect to q of x. So du dq of x will be equal to, for the derivative, we're just going to take this portion down and then subtract this power by 1. So we have 0.5 times qx raised to the power of 0.5 minus 1, right, times q of y raised to the power of 0.5. Q of y raised to the power of 0.5 just becomes like any other constant here. We carry it along. Okay, so this would be equal to 0.5 times q of x to the power of negative, right, 0.5 times q of y to the power of 0.5. Okay, so this is our mu q of x. Same thing. Remember, these are the same thing. All right, so now we want q of y. Same thing as MUY. This is MUX. This is the same thing as MUY. I just want to be consistent here and show you every possible way you could see this, so you understand that it's really all saying the same thing. Okay, so we have du dq of y. What is this going to be? Just quickly do that. You can pause at this point and solve it. Good. So now we're working with q of y here. So we're going to take this and bring it over, right? And then subtract 1. So we end up with 0.5 times q of x to the power of 0.5 times q of y to the power of negative 0.5. How did we get negative 0.5? Right, we just have 0.5 here minus 1, our derivative rules. So this will end up being equal to 0.5 qx to the power of 0.5 qy to the power of negative 0.5. We've gone through quite a bit of calculation here, but remember, we've taken our time. We've gone through this step by step. Step by step. So ensure that nothing is lost in the communication, and we talked about how we got to this point. So what we've done right now is find the slope of this indifference curve, right? Once we combine them together, and we know why we need that. We need it for that optimality condition. So MRS, let's write this in red. MRS will be equal to negative mu x over mu y. Remember, we said that mu x for us is just mu q of x over mu q sub q of y. Hopefully we've done this. So this would be equal to, what was mu q of x? That's right, we have that over here. Let's bring that down. So this is 0.5 times q to the power, qx to the power of negative 0.5 times qy, to the power of 0.5. And this is going to be divided by, yes, that is correct, mu q of y. We bring that to the denominator, so we have 0.5 times q of x, 0.5, q of y, negative 0.5. So we'll notice some things happening here. First of all, anything raised to the power of negative, so if we have a raised to the power of negative 2, this is the same thing as saying 1 over a to the power of 2. Okay, what does that mean for us? So that q of x raised to the power of negative 0.5 is the same thing as saying 1 over q of x to the power of 0.5. We can just bring q to the power of 0.5, this here, we can just bring this down, right? And it will just be divided by q to the power of 0.5. We'll see that next, okay? Also, we have q of y there in the denominator, right? Q of y to the power of negative 0.5 is equal to 1 over q of y to the power of 0.5, except it is in the denominator. So it's like we have 1 over q of y to the power of negative 0.5. So we can do that there. We know that this is just 1 over 1 divided by 1 over q of y to the power of 0.5. If you have a division sign, it changes to multiplication sign by flipping the fraction. So this would be equal to 1 over 1 times q of y to the power of 0.5 divided by 1. So what does that mean for our equation here? Well, it means that we can take this up to the numerator and take away that negative. Right, we went through quite a bit here. Hopefully that was clear. Again, as we go through, if you have any questions, let me know. Okay, so let's apply that to our, I should have undone first. Okay, let's apply that to our equation. The reason why we're doing this is so that we can simplify our MRS equation, or the slope of that IC curve. So when we bring it into our optimality function, it's a nice and simpler function. So this would be equal to, let's keep with the red, this would be equal to 0.5 times q of y to the power of 0.5, the original, times, we'll bring the other one up here, q of y to the power of 0.5. Notice that we now have y's on top, divided by 0.5 times q of x to the power of 0.5 times, that's the original, this is the one we're bringing from the numerator down to the denominator, q of x to the power of 0.5. Again, we have just x's in the denominator, and we have that these 0.5s can cross out. So this would be equal to q of y raised to the power of, since we're multiplying the same base, we can just sum the powers. So 0.5 plus 0.5 divided by q of x raised to the power of, yes, that's right, 0.5 plus 0.5. Very good. So we end up with just q of y over q of x. Now, please note that we dropped our negative along the way, right? That's not something we should do. We should always hold on to that negative. Right, so our MRS, the slope of that indifference curve given our utility function is equal to negative q of y over q of x. Okay, so far so good. It looks like our calculations hold up. So now let's combine this. Now let's do that in that. Now use this in the optimality condition. Optimality condition. MRS is equal to MRT. Okay, so we have that MRS here is equal to negative q of y over q of x. Now we're going to set this equal to MRT. Remember, MRT is equal to negative p of hold on. Let's see where I had that earlier. Yep, there it is. P of x over P of y. P of x over P of y. There's another video that describes what this is and how we actually derive this, right? How we know this is the slope, rise over run, of that budget constraint, slope of the line. Okay, so this condition here tells us that negative q of x, negative q of y over q of x. What is this? Good job, MRS is equal to negative p of x over p of y. Notice that they both have that negative sign, so it's crucial that we don't drop our signs or that we have checks as we go along the way. This is a good check here at this point. Right, so we have MRS equal to MRT. Now with this condition, we can solve for QY or QX. So we want to see how QY relates to QX given these prices. So let's go with QY. So from this, right, solve for QY, the numerator, right, so one on top. So we'll just have that QY is equal to, those negatives can cross out, P of X over P of Y times, let's use the dot for times here, times Q of X, right? So this is how they relate to one another. We can call this equation 1. We went through all of these calculations so that we can determine how Rory relates good 1 to good, so good y to good x, given their prices. But we can't stop here because we know that Rory has an income limit. She has a budget limit or constraint. So we need to consider constraint, her income, her budget for this. So remember that the budget constraint is I is equal to P of X times the quantity of X purchased plus P of Y times the quantity of Y purchased / consumed. So since we already know what Q of Y is from our optimality condition, we can plug that into here. So we can find Rory's actual Q of Y star to find Rory's and Q of X star. This is what we need, so we can then find Rory's demand curve. Right? So basically this would be Rory's demand function for good Y, and we know that in this demand function Rory's always optimizing her choice or her utility, and the same is true for this. Right? This is the demand function for good X, and Rory is always optimizing her utility in this function. So with that information, right, we know we're chugging along to the right destination. So let's complete this. So if we have that Rory, again, remember we're doing this for any I, any P, any P of X, any P of Y. So we have that I is equal, in other words, you're just leaving those function variables as they are. We're not plugging in any numbers. So this would be equal to P of X times Q of X plus P of Y times, that's right, we plug this in, right, times P of X over P of Y, Y times Q of X. Let's do a small parenthesis there. Okay, so with that we can carry on solving. These will cross out, so we're left with P of X times Q of X, so I is equal to, we're not dropping that, plus P of X times Q of X. Right, so we have that I is equal to 2 P of X, Q of X. So therefore, Q of X star, which is what we want, right? This is the goal, her optimal demand function, is equal to, just divide both sides by 2 P of X. Okay, I'm gonna skip that, writing that down, but hopefully it's clear. 2 P of X, which is divide both sides by 2 P of X. So we can see here that this is Rory's demand function, Rory's optimal, which is what we want. We always want that optimal, especially if we're deriving it. Rory's optimal demand function given, for good X given her budget or income, the price, and the price of good X. Notice that this demand function for good X, it is not a function of, in other words, what's missing? Right. P of Y, right? It's the price. Bear with me. I need to delete that. I'll go away. Control Z. Control Z. There we go. And P of Y here is the price of the other good. So we can say that this demand function for good X is, or depends on Rory, or the consumer's income, which we called I, and the price of, well, let's say its own price, and its own price P of X. It's being the demand function does not depend on the price of the other good. Right? And we see that here. On the right hand side, we only have income and price of the good X. And this is for Q of X. Okay, so we know Q of X, but we're not stopping there because we also need to know Q sub Y star, optimal demand function for good Y. So we know what that is. Right? We already have how they relate to each other from here. So we can, actually, no, not from here. We need something even better. Why not? Yeah, from here. It's going to skip some steps, but let's not. Let's bring this all the way down. To where we need it, which is here. Right, so that is P of X over P of Y times Q of, we have to become consistent, Q of X. Okay, so we already know what Q of X star is going to be. So we have, or is rather, P of X over P of Y is equal to, excuse me, Q of Y star is equal to P of X over P of Y, which is bringing that down, times Q of X star, which we know is I over 2 P of X, times I over 2 P of X. Okay, these two cross out, and we are left with I over 2 P of Y. Right, so Q of Y star is equal to I over 2 P of sub Y. Therefore, we have derived the demand functions for Rory of good X and good Y. So we have Q of X star is equal to I over 2px, and Q of Y star is equal to I over 2p of Y. Remember when we first started, before we did this, we defined a number of things, right? One of them was what all these variables mean. So all we're saying here is that, so for instance, let's describe this. Actually, we've already done Y, so X matters, let's do Y. So this is the quantity of good Y demanded is a function of I and P of Y. Specifically, this is how they relate to each other to find our optimal demand for, or consumption choice for Rory. Okay. We can stop at this point. We've derived that function, but if you want to carry on, we can actually go ahead and derive, okay, do the graphical derivation. I think that's going to be a different video. Graphical derivation. Next. Hopefully this was useful to you and some things were cleared up. If you have any questions, let me know. Best of luck. See you around.